All right, we're going to go ahead and start part 3. So, here we go. ACT scores at Ardrey Kell High School are normally distributed with a mean of 26, standard deviation 3. ACT scores at Providence High School are skewed to the right with mean 25 and standard deviation 5. Let's say that we randomly select 25 students from AKHS and 30 students from PHS. Use the information given to describe the sampling distributions of the average ACT scores for the two samples. All right, so for this, I'm going to give you just a little bit of a hint, and then I'll give you some time to work on it. So both of them are going to be approximately normal, but I want you to try to figure out why. And then the mean is going to be equal to the mean of the population for both. And the standard deviation for both is going to be equal to the standard deviation of the population divided by the square root of the sample size. So go ahead and pause, try to fill this table out, and then we'll go over it together in a bit. All right, so for AKHS, it's approximately normal because the population is approximately normal. And that just tells us that right in the problem. So where does it say that? There we go. So because the population has a normal distribution, that means that our sampling distribution will also have a normal distribution. For Providence High School, it's approximately normal, and that's because the sample size, 30, is greater than or equal to 30, which means we can use the central limit theorem. So even though the population is skewed, because the samples are large enough, we can go ahead and say that the shape of our sampling distribution will look approximately normal. All right, so for my means, the mean at AKHS is 26. For the population, that means sampling distribution will have the same mean. And at Providence, same thing. I can just grab my population mean and use that. For standard deviation, it's going to be the standard deviation divided by the square root of the sample size. So for AKHS, the standard deviation is 3. And sample size is 25. So 3 divided by root 25 gives us 0.6. And then for PHS, same thing. The standard deviation here is 5. My sample size was 30, so it's 5 divided by square root 30, which gives us 0.91. All right, for part 2, I'm actually gonna, let's skip ahead and do notes, and then we'll come back and go over parts 2 and 3. Okay, so if we're doing a sampling distribution for a difference of means, and that's gonna look like this, x bar sub 1, x bar sub 2. We're going to talk about how to find the shape. You need to check both sampling distributions. To see if they're normal. And there are 2 ways that we can show that. So it would be either population is approximately normal, or sample size, n, is greater than or equal to 30, and that's with the central limit theorem. All right. To find the center, again, I'm just gonna, I always set up space to talk about normal calculations, and then I'm just like, we should just use normal CDF and make our lives easier. Okay, for other things, so we have the center. So basically, to find the center of the difference, you are going to take the mean for the first population and subtract the mean from the second population. And then for variability, it would be, okay, so to find the standard deviation of the difference of two sampling distributions, so x bar sub 1 minus x bar sub 2. To do that, it's going to be big square root, standard deviation of the first population squared divided by the first sample size, plus the standard deviation of the second population squared divided by the second sample size. And my subscripts here just refer to the different populations. So like these like little ones would just be like the first high school. The little twos would just be like the second high school. So it's not like you have to do anything with those numbers. I'm just trying to be clear about like which sampling distribution we're getting information from. All right, so based off of that, I want you to go ahead and try to answer question 2. Describe the mean and the standard deviation and the shape based off of what we just went over in our notes. I'll keep the notes up for a sec, so pause now if you want to look at these while you're working. And when you're ready to go over them, hit play. All right, so our shape is going to be normal. Because both sampling distributions are approximately normal. To find the mean, I'm going to do 26 minus 25 to get 1. Simple as that. So I'm just subtracting my two population means. To get the standard deviation, I know I sort of gave you a more complicated looking equation. I should actually go back and edit that real quick because there's a faster way to do it too, if you already know the standard deviations of your sampling distributions. So that, if you know those, which we already do, we know they're 0.6 and 0.91, I can write this out as the standard deviation of my first sampling distribution. I'm going to want to square that. And I'm going to want to add the sampling distribution for my second sampling distribution and square that. Both of these work just because we already calculated our standard deviations of the sampling distribution. The second one's easier. Okay, so based off of that, I'm going to do big square root. And then it's going to be 0.6 squared plus 0.91 squared, which will give us our standard deviation of 1.09. And this should just be a 1. It sort of looks like a T in there. All right. Last question here before we jump to, are there any more notes? No. Okay. Last question before we do our check for understanding then. Asks you to calculate the probability that a random sample of 25 AKHS students has a higher mean ACT score than the random sample of 30 PHS students. When you first look at this, it might look a little bit impossible. Like, how are we supposed to like set up that comparison? But if we think about it, what we're looking for is that we want to know what's the probability of the mean from the first sampling distribution. If I subtract the mean from the second sampling distribution, I want that to be more than 0. Basically, I'm trying to figure out, okay, what would be the chances of AKHS having a higher mean? That means that if I subtract AKHS minus PHS, I want to get a positive number. If it was, if we were trying to calculate the probability that it would be a lower mean, then we would want this part to be less than 0. Okay, so I'm going to go ahead and sketch out my normal curve. The mean difference is 1. I'm going to go ahead and label, so I've got 1 and 1.09 for my mean and standard deviation. And we are interested in what is the probability that the difference is greater than 0. So this is what I'm looking for. I find sketching this out really helpful because it helps me identify my lower and upper bounds really easily. So I'm going to go ahead and do that. So normal CDF, my lower bound is 0, upper bound, random big number, mean, and standard deviation, we know. I grab my calculator and go plug all that stuff in. And I am getting 0.82 for that. So, and that kind of makes sense too, like 0.82 is a majority, and it looks like I have a majority shaded here. That's another reason to sketch a picture, is that it just gives you like a quick check to see if that's looking right. All right, I want you now to go ahead and work on your check for understanding. When you're ready to go over it, hit play. Otherwise, pause for now, take a few minutes, and then when you're ready, we'll go over it together. All right, so our situation here, we're trying to figure out where it's more expensive to live. Excuse me. Question A, what is the shape of the sampling distribution? With questions like this, like we sort of like hope it's going to be normal, otherwise we can't even really describe it, but we have to like show why, okay? So for A, I can say it's approximately normal. Oops, that's okay. Because both populations are approximately normal. And I know that just because it tells me in the problem. It tells me that living expenses in California have a normal distribution, and Florida, same thing. So because both of those have normally distributed populations, I can go ahead and say that when I subtract the sampling distributions, that will also look normal. All right, next it's asking you to calculate the mean and the standard deviation. All right, so to find the mean of the difference between two sampling distributions, and I'm going to use sub C for California and sub F for Florida. To do that, all I need to do is take my population mean for California and subtract my population mean for Florida, which gives me 10,800 minus 8,500, which is 2,300. Okay, and then for the standard deviation, I'm going to go ahead and use that equation, but I'll write it all out. So the standard deviation of the difference between two sampling distributions I'm going to go ahead and fill that out. So it's going to be my standard deviation for California squared for the population divided by my sample size for California plus my standard deviation for Florida squared for the whole population divided by my sample size for Florida. So filling this out, it's going to be 3,200 squared divided by 16 and 2,700 squared divided by 9. And when we do that, we get $12,004.16. All right, so we're going to need this for the next problem. I'm going to put those in boxes. All right, last part. Calculate the probability that the average monthly cost of the 16 randomly selected California residents is less than the average monthly cost of the living expenses of the 9 randomly selected Florida residents. So here I'm looking for, I'm just going to put this in math writing, the probability that from my sample of Californians and their living expenses, if I subtract my average from my Floridians' living expenses, I want that to be less than 0. Because we're looking for the Californians being less than the monthly cost for Florida. Okay, so I'm going to go ahead and sketch this out. I know the mean is 2,300. We calculated that in the last problem. labeling that this is normal with the mean and the standard deviation here. And we are looking for the chance that the difference will be less than 0. Okay, so normal CDF. My lower bound is going to be a negative huge number. My upper bound is 0. My mean and standard deviation, we have those. All right, so I'm going to type all that stuff in and see what we get. And yep, I'm getting 0.028 for the probability that the mean among the Californians is less than the mean among the randomly selected Florida residents. All right, cool, that's it. So the other things you have to work on for this week are multiple choice parts B and C. I highly encourage you to look over your mistakes after you've submitted it, because we have a weird sub situation right now. That's using the AP Classroom like that is one of your only ways to get specific feedback on what you understand and what you don't. So please go ahead and make sure you're reading over the feedback after you've submitted.